Hey guys, so today we're going to be looking at the Unit 6 test review, and we're going to go to the back of the worksheet, and we're going to look at 9, 10, and 11. So the directions say for 9 through 11 clearly indicate the necessary steps, including appropriate formula substitutions, graphs, charts, etc. A correct answer without justification will receive no credit. So number 9 tells us the graph shows the estimated populations in thousands of people of the Buffalo, New York area and the Charlotte, North Carolina area. Use the graph to find the year in which the populations of these two areas were the same. So we have one line that represents the Charlotte population and another line that represents the Buffalo population. And if we want to find the year that the populations were the same, we would have to find that intersection point, because the intersection tells us, okay, this is where Charlotte and Buffalo's populations meet. So now we're going to look, okay, we want to find the year. So we can see right from the start that it's between the 5 and 6 mark on the x-axis. But the x-axis is marked by years since 1990. So if it's between the numbers 5 and 6 on the x, that would be between the years 1995 and 1996. Because it's years since 1990, and 1990 plus 5 is 1995, and 1990 plus 6 is 1996. So if the intersection is between 1995 and 1996, that means that the year that the populations were the same is 1995. It's because it'd be during the year 1995. So now we can look at number 10. So number 10 tells us 2 times a number added to another number is 25. And 3 times the first number minus the other number is 20. Write and solve a system of equations to find the numbers. So first, whenever we're writing a system of equations that's from a word problem, we have to write our let statement. So we can write let x equal the first number, because we're finding 2 numbers, and let y equal the second number. Then once we write our let statement, we can go ahead and write our system. So we can use the word problem to help us do that. So the first sentence tells us 2 times a number added to another number is 25. So 2 times a number, so we can write 2x, because that'd be 2 times one of the numbers, which is x, added, so plus, to another number, so the other number is y, is 25. Is means equals, so equals 25. The next sentence tells us 3 times the first number minus the other number is 20. So 3 times the first number, so the first number was x, so 3x minus the other number, so the other number is y, is 20, equals 20. So then once we have our system, we can solve it. So when we're solving systems now, we can think to ourselves, which method would be the easiest to use? In this case, we can notice right from the start that we have a plus y and a minus y already set up perfectly for us. So because of that, we can use elimination. So when we use the elimination method, the plus y and the minus y will cancel when we add the system down. So we would do 2x plus 3x gives us 5x, and 25 plus 20 gives us 45. To solve for x, we divide both sides by 5, and we get x equals 9. So then once we find our x, we still need to find our y, so we can substitute that x value into either of our 2 equations. So we have 2x plus y equals 25 if we just want to substitute it into the first equation. Substitute 9 in for x, so 2 times 9 plus y equals 25. 2 times 9 is 18, plus y equals 25. And then we would subtract 18 from both sides, and we get y equals 7. So our coordinate would be 9, 7. So now we can go on to number 11. So number 11 tells us, Mr. Santos, the curator of the Children's Museum, recently made 2 purchases of clay and wood for visiting an artist to sculpt. Use the table to find the cost of each product per kilogram. So since we have a word problem again, we can write our let statement to start. So for this, it wants us to find the cost of each product. So we know that our x and our y is going to have to do with the cost. So in our table, we see clay and we see wood. So we know one will have to be clay and the other would be wood. So we can just say, let x equal the cost of clay, and let y equal the cost of wood. So then we need to write our system of equations using the table. So looking at that first row in the table, we see 5 and 4 and 35.50. So clay has 5 kilograms, wood has 4 kilograms, and the total cost is 35.50. So to write that using our x and y that we defined, we have 5x plus 4y equals 35.50. Because the clay is x, they got 5 kilograms, the wood is y, and they have 4, and then we have the total cost at the end. So our second equation is going to look super similar using that second row. So now we have 3.5x plus 6y equals 50.45. So then we have to think to ourselves, what would be easier to do, elimination or substitution? For this one, since it's set up so that the x's, the y's, and the total cost all match up in their rows, it would be easier to use elimination. So what I see is that the easiest thing we could probably do is to eliminate the y variables. So to do that, we can just multiply a -6 through the top and a 4 through the bottom so that our y's will cancel. So doing that, we get -30x minus 24y equals -213. And our second equation is 14x plus 24y equals 201.8. Then our y's cancel. When we add, we get -16x equals -11.2. We would divide both sides by 16 to solve for x, and we get x equals 0.7. So then we need to solve for y, so we can plug 0.70 into either of our 2 equations. So I'm just going to plug it into the first equation. So 5 times 0.70 plus 4y equals 35.50. 5 times 0.7 is 3.5 plus 4y equals 35.50. And then we can subtract 3.5 from both sides. And then I'm going to go up here. And we have 4y equals 32. Divide by 4 on both sides, and we get y equals 8. So we have our y and we have our x. So now we have to write these as an answer. So it would be 70 cents for clay and $8 for wood. Alright, that's it for this video.